All right, just starting that so it's doesn't have that much waiting.
Right. Okay, we can get started. Hello, everyone, and welcome to Programming in Robotics today. My name is Professor Angela Wells. I am a member of Black in Robotics, Chief of IoT for Lumina Energy, and today we are going to actually have a Programming in Robotics workshop. This is an exciting field that combines the power of coding with advanced robotics technologies to create intelligence machine capable of performing a wide range of tasks. And so I'm going to allow everyone to introduce themselves and the TAs. And so I'm going to pass this off to the instructors, Alex.
Hi, my name is Alex. I'm a fifth year robotics PhD student at CMU, and I do robot motion planning.
Okay. And who would you like to pass it off to?
Okay, we'll do it like that.
Yes.
How are you? The next person on my thing is Christopher.
Hi, my name is Christopher. Um, can you hear me? Yeah.
Yep, we can
Hello?
hear you.
Okay. Yeah, my name is Christopher. I'm a graduate. I'm a graduate in electrical and electronics engineering, and I'm very interested in robotics, especially in what robotic systems can do in surgical operation rooms. I've been a tutor, a STEM educator to students in high school for over 2 years now. I'm really interested in knowledge transfer. So I'm happy and excited to be here today. Thank you.
Great. Thank you, Christopher. Okay, let's pass this off to Serial.
Okay. Yeah. Yeah. Hello, everyone. So my name is Cyril, and I am a member of Black in Robotics, and currently I also work with Microsoft vendor as a cloud technical support engineer. And I'm passionate about STEM, and I'm also passionate about robotics. And it's been nice to learn and teach our students as well. Yeah. Cool.
Great. Thank you, Serial. Okay. Next, Maddie.
Yeah. Hi everyone. My name is Madi. Well, my full name is Mahadirek Albayo, so go by Madi. I'm a recent graduate from Wellesley College, and I finished in physics. But I'm also passionate in robotics. I'll be working in Boston Metal this year um, as a data analyst, and yeah, I'm very excited to be here and teach what I can.
Great. Thank you. Okay. Let's go to TJ.
Hey everyone, I'm TJ. I'm a third year PhD student in mechanical engineering. My research is
Oh,
focused
we
on.
can't, I can't hear you.
Oh no.
You- It's your volume.
Okay, you can just come back to me later. I'll try and fix it.
Okay. Um, let's see. Okay. Thank you, TJ. Okay. Stephen.
Hi there. Hi, yeah. So I'm Steven. I'm a recent graduate from in systems engineering in Canada. I'm a embedded robotics developer by day and just enthusiast by night.
Okay, great. And let's see, did I miss anyone else? Because we have like 15 here.
Also, we usually do TA instructions at the beginning of the breakout rooms. We could continue to keep doing this if you'd like, but there is a slot for everyone to introduce each other when we're in the more interactive setting.
Okay, all right.
I've not
Okay,
introduced myself.
okay,
Uh,
go ahead.
I'm Kayode Akoni by name. I finished my master's in AI engineering and robotics, and I'm very
Mhm.
passionate about robotics and STEAM or STEM education, and also on algorithm accounting, especially how the emerging technology has to affect human rights, especially in our AI-enabled future. I'm happy to be here to teach and to learn and to make sure I put in my best in impacting knowledge to others. Thank you very much.
Great. Well, we're happy to have you here. And let's see, Alex, did you introduce yourself?
Yeah, I think we're missing Ranisha's introduction.
Okay.
Yep, they're not here today, but they're one of
Okay.
they helped a lot with this.
Okay.
Would you like to read their introduction? I think it's in the thread to you.
Yes. Okay. We have three instructors here today. We have Alex LaGrassa, correct?
Yeah, you don't have to read our bios. I think we introduced ourselves
Oh,
already.
okay.
Yep.
And Rainisha Ray and TJ Thomas. And also, I'm here. My name is Angela Wells, Professor Angela Wells. And so I am very excited to be here. And let me move on to explain the mission of Black Robotics. Blacks in Robotics is an organization. Equalities found in our robotics community by focusing on three primary pillars: community, advocacy, and accountability. We want to bring robotics community together around these initiatives. Black in Robotics brings together a global network of Black roboticists, allies, organization sponsors, contributing to the goal of enhancing diversity, inclusion of equality in robotics. We believe that to we believe to see an increase in presence of Blacks and underrepresented minorities in robotics, and we must actively build communities advocates for diversity and encourage accountability. So today I'm going to turn it over to Alex, and Alex, you may begin.
All right, thank you, Professor Wells. Today, these are learning goals for today. First is we are going to modify and write Python code. This is getting started in program. So writing expressions and calling functions that already exist. I want to highlight that this is an iterative process. We're going to make mistakes. There's going to be errors, and that's expected, normal, and we're going to work with that. The second is the robotics part. We will command a robot to go to a specific set of joint angles. So yeah, like arm angles, and to a particular 3D location. The last goal for today is to sketch out a procedure of taking some robot behaviors that we now know how to do from that blue box, commanding the robot to do those things, to make something that's more complicated, like a dance or grasping an object. And the priority here is just to get confidence in getting started with programming and robotics. We want you to go back to the labs and to continue to work on it, to continue to develop your skills. Yeah, and we'll go back to these as at the end as well. Here are the kind of the expectations for this class. it's supposed to be quite interactive. There is some lecture component, but we try to keep it to a minimum. Most of the work and most of the learning will be with your TA in breakout rooms. The format that we expect is that one student will be sharing a screen at a time. Everyone fills out the code and the lab together on their own computers as well, but one student will be sharing a screen. Discuss and ask the TA questions. The TA can guide the discussion, but it should be a student who is typing out the code. We will also have the main room for these like lecture bits. And if there's anything that you can't resolve within your rooms, please come back to the main room. Finally, we expect everybody to treat each other with respect and kindness because everybody is important here. Also, if you have questions, please put them in the chat and we can do our best to answer them during. I didn't write that on the slides, but anything else is to be talked about in the breakout rooms. So as a reminder, breakout room is for group discussion and working through the lab. This is where the learning happens. And main room is for lecture, where you'll see things, but it's okay if you don't learn it at that point. And any sort of troubleshooting with the lab if there's something that that isn't working. All right. Oh yeah, and please rotate who shares and ask questions. And for pacing, prioritize anything that says it's not a challenge, and you can come back to the challenges. And if you get stuck on any one part for more than 5 minutes, that's not what we expect. It's not that anything is going wrong, but please come to the main room so we can figure out what's blocking people. This is the structure of the class. First, we're going to do some basic programming stuff. The longest lecture bit will be right here of just some of programming. Then we'll do our first breakout room session for 20 minutes. Then most of the lab happens here. There will be a 5-minute lecture given by TJ. Then we will have 40 minutes in a breakout room. And finally, we will do a wrap up with another short lecture and then the third part of the lab. Finally, we'll come together, share lessons learned, discuss together. So this is the format. And we'll start with the programming part. So first, a way you can think of programming is like a recipe. So we have definitions and we have commands. A definition is a label for something. So we can have a slice of bread called slice 1, a different slice of bread called slice 2, and jelly. To do things with these slices, we have commands, which are actions or instructions. An example of a command is to spread or to place. This is an example of what a recipe for a peanut butter and jelly sandwich may look like. I'll just highlight 2 examples. So second is spreading. This is the action. Jelly, which refers to this, on slice 1, which refers to this. And you can do something like place slice 1 on top of slice 2. So this is doing actions with the objects. In coding, it's a language, and like any other language, like Spanish or like Chinese, it has rules of how letters and numbers need to be arranged and what that arrangement means. So if in math, we decide that putting a plus sign between numbers indicates to add those 2 numbers. Similarly, in Python and many other languages, when we're giving a definition to a label, we put the label on the left side, you put an equal sign between them, and we put the definition on the right side. So this is just an example of the rules for the language. There are many different types of programming languages. There's Python, which looks like this. Some of you have also maybe worked with other languages such as Java. And yeah, if you want to shout out any other programming students, any programming languages that you've learned, feel free to type those out in the chat. And here are the concepts we're going to learn. There are many other concepts in programming and in Python, but we're going to focus on these building blocks. One of them is variables, which are those names. Next is printing something to the screen, so outputting something to the screen. Commenting, which explanations for code. This one is really important. This one is functions, so doing things with existing libraries or tools that other people have created. And finally is lists, a collection of objects. So first we'll start out with printing. Printing outputs text to your screen. For instance, when you're printing, you put the text in quotation marks, and it will show out on the screen. For this part of the lesson, I'm also going to show an example in Python. So look on the left side of the screen. So if I want to print, my name is Alex, I do print. These parentheses indicate a function, which we'll go through again. But for now, just you can just think of it as print, then parentheses, the text in quotation marks, my name is Alex, and it will output on the screen. All right, and I'll give like 5 seconds for people to put questions about print. This one tends to not get questions, so TAs can answer if people have that. All right, next is comments. A comment is a hashtag next to text, and you're supposed to use it to explain code like this. This is printing code. Now, when you're explaining code, it doesn't actually run anything, so it can, yeah. So accordingly, you can also put a hashtag next to code that you don't want to run. And in the lab, we will be using this as a tool. So this, if I put print hi here with the hashtag next to it, it won't run. Next is variables. Variables are how we assign labels to data. We're reviewing this again because this is really important. This is one of the building blocks. The value goes on the left. The variable goes on the left and the value goes on the right. So if I want to create a variable called variable name, I put it here, equal sign, and the value on the left, on the right. Then I can print out that variable. Let me do a slideshow mode. Oh, that's unfortunate. Okay. This is functions. So functions take in an input called arguments. So in a divide function, the arguments are numerator and denominator separated with a comma. So these are inputs. The inputs can be empty as well. Functions do something. When a function does something, we say we're calling the function. And lastly, a function outputs something, which we sometimes call it return, which can be nothing. So a function can do something and not return anything. There could be no outputs. For instance, if we call divide, these are inputs, 1 and 2. The call will do the division operation, and the output is the result of dividing 1 by 2. And if we the order of the inputs matters. So if we do divide 2 by 1, we get a different value. Next two concepts are about lists. Lists are collections of data. You know it's a list when there's a bracket, square brackets on either side, and separated by commas. So I can make a list called my list. Same rules for the variable goes on the left, the data goes on the right. And lists can contain anything, not just numbers. It can also have text. So in chat, type a different list. And I will pick one. All right, so the activity here is to type a different list. I will give an example of another list. And yeah, students, please type in a list. Okay, there we go. All right, yay, more lists. Okay. All right, so we have a list. That's so small. No, I'll just leave it like that. Okay. Brackets can be used to index into a list. So suppose we have a list that says 1, 2, 3, 4, 6. I'm going to go back to slideshow here. The indices start at 0. So the first is going to be the 0th. The second is going to be the 1th. So if we want to get the first value of my list, we put my list 0. And then the 1th will be 2. So in chat, what will my list 4 be? Yep, 6 is right. Now, if we want to modify the list, we can index into it and then modify it. So I'm going to pick robotics 3 Sunday. And I'm going to call it Patrina's list. Oops. I'll have to retype that. Robotics 3 Sunday. Now, if I want to change this list, so that way the first item says car, how would I do that? So I want to change the first item to be car instead of robotics in chat. Nice, yep. So if I do that, list 0 equals car, then, and if we look at the list again, so we can do print Katrina's list, then we see the first item is car. So that's modifying lists. In robotics, one of the big things we use this for is for containing data like the joint angles or positions. So we'll see those a bunch. All right, and to recap, we've talked about variables, which assign labels to data, printing, which outputs text to your screen so you can get information about some of the variables, comments, which are used to explain code, or to stop code from running, functions, which perform specific tasks, and they have a name, you call them, they use parentheses for the inputs and a comma in between them, and these are the inputs, and lists, which are collections of data. And again, this is kind of a lot all at once. We don't expect people to work with things or to really understand until they work with things, and that's completely fine. So we're going to go into the lab. So how do we run code on the web? This is a way of not having to do everything different for everyone's computer. So we're going to be using something called Google Colab. Google Colab it's like a Google Doc, but yours doesn't change other people's in the way we've set it up. To edit code, you double click the code block. To run code, there's a play button, so you can just press play. The instructions will be in the lab as well. And for editing text, you double click the text box and then type. So when we go into the breakout rooms, this one's going to be about 20 minutes, but if we find people are finishing quickly, we might close them earlier. And please start by introducing yourself with your name, what your interests are in robotics, and then together think of something you would want a robot to do, and how you would describe instructions to a robot to do that task, kind of like describing it, kind of like the peanut butter and jelly description. Yeah, so I'm going to put the link to the lab. Please open it in another browser because it's a little hard to share links once everyone's in breakout rooms. And as a reminder, work with each other and the TA, and one student should share screen at a time. Professor Wells is going to open the breakout rooms, and please arrange yourselves. That way there's at least one TA per room. And it's perfectly fine to have multiple TAs per room, but make sure one TA per room. Professor Wells?
Yes, I am getting ready to assign right about now.
Okay, yep. Thank you.
Why didn't you do it?
Okay. Looks like people are back. Yeah, I think TJ, it's whenever you want to go for it. To start.
Okay, can everyone hear me okay?
Mm-hmm.
Cool. All right. Yeah. So sorry, things are a little weird. I'm using my phone as my microphone, so bear with me here. But I'm TJ. I'm a third-year mechanical engineering student, PhD student at Carnegie Mellon, and I'm going to be talking about the robotics aspect of this lab. So first of all, what is a robot arm? So many of you have probably seen them in movies, or if you've been in a robotics program, you've seen them before. But it's defined as a programmable machine that can perform repetitive tasks accurately. It's defined by also resembling a human arm, which we'll talk about a little bit more. And they can collaborate with humans, or they can replace dangerous human tasks. So they can work together with humans, or just completely, take over the job as well. So talking about the anatomy, so it's very similar to actually a human arm. It's kind of how robot arms were kind of inspired by. So in a human arm, you have the shoulder joint, you have the elbow joint, you have your wrist joint, and then you have your hand, which is an end effector. And an end effector is basically anything at the end of an arm or a robot arm. In our case, it's going to be a gripper, which we'll talk about at the end. But I think this is blocking. Here we go. Yeah. But in robots, we can control the arms by commanding the joint angles. So you can see there's 3 joints here, and each joint has an angle. And if we just tell the robot to move to a certain joint angle, then the whole robot arm is going to move somewhere. So that's pretty much the core concept of this lab, just to really understand and hammer down. So also feel free to ask questions throughout the lab. I know this is kind of more the complex section. So yeah. Okay, so like I mentioned earlier, joint angles are kind of basically just the angles of the joints of the robot arm. It doesn't have to be just 3, it can be 6, 7, 8. It just really depends on the geometry of whatever you want to make your robot into. So they basically indirectly specify the position of the robot parts. So in the chat, just making sure y'all paying attention, just want to see how many joint angles does this robot on the screen have. Okay, 3. Yeah, there we go. All right, cool. All right, moving on. So also position. So I'm sure all of you have heard about position in other contexts, but in robotics, position describes where the object is typically in 3D. So it's basically kind of the mathematical description of where this object is. So for example, this red block here is basically 0.1 units in the X direction, 0.1 units in the Y direction, and 0.1 units in the Z direction. And that is our position, basically. So here's where it gets a little complicated. So just bear with me here and feel free to ask questions. So there's two major ways where you can command the robot to get to a certain position of interest. So first we have forward kinematics. So you basically start out knowing the joint angles. So let's say you have some kind of sensor that can know exactly where the robot joint angles are. And let's say you want to get the arm to some kind of position, you use something called forward kinematics, which is basically a set of equations and a set of functions that will translate the angles into the position. So here, the angles, what you want to really just hammer down here is that for forward kinematics, the angles are the input and the position is the output. And we just want to know the position of the gripper at the end. And the opposite of this is inverse kinematics, where first you start with the position of the object or whatever you want to sense. So let's say we have a camera that can see exactly where this apple is on a table, but we don't know how to get the robot there. So you use inverse kinematics which is also another set of equations and functions. And that will basically translate that position you get from the camera to the joint angles that the robot needs to command to pick up the apple. So you don't need to know how the math works at all, just kind of know that these things exist. You're going to be able to use functions like this in the lab. So just kind of a general overview again. Once again, forward kinematics start with angles and with position, and the opposite is for inverse kinematics. So you start with position and then you end it with your joint angles. So I know that's kind of a lot of information, so feel free to ask questions in the breakout rooms, but I'm going to pass it back to Alex.
All right, thank you, TJ. All right, again, There's information there. It's a lot, but it will make more sense as you start working with. So we're gonna go back into the breakout rooms. This time you can go if you want to continue working on programming. You should join the programming breakout room. You can come here and we can assign you to it if that's what you want. And everyone else, you can move through rooms. We'll probably move a couple people into room 4 just so we're a little bit more split up now that we have more TAs. So I'm going to add one more room and yeah, I'm going to reassign everyone, I think. No, okay. Open all rooms. And again, if you want to work on programming, come back here and we will add you to programming. And we will move a couple people around just so there aren't too many people per room. All right, good luck with the lab. We'll have about, we're going to get back together here at around 4 p.m. Yeah. And yeah, and then TJ is gonna wrap it up. Okay. No rooms. No, isn't. Oh yeah, thank you. For 30 minutes. Oh, it's been a while since I've done like cross time zone stuff. Uh,
All right, everyone's back.
I think so.
Yes, I'm back.
Okay, cool. All right, well, hopefully that was a good experience for you guys. Seems like some people finished it, so hopefully it was useful. So now that we can move the arm, how do we actually get it to pick things up? How do we get the end effector or the gripper to actually grip things and do something useful? So first we're going to start talking about, I'm going to just kind of show all these steps. We're going to first talk about like actually grasping the object. How do we get to the object and pick it up and move it somewhere? So first you have to move to above the object. And with this step, you kind of have to know the height of the object so that you don't, run into it. Then you have to open the gripper and you move down to the object and then you close the gripper. And this part at the end is really important, especially for the discussion later. You have to make sure that the width of the grip is slightly less than the object width so that you can actually squeeze it a little bit, because if it's exactly the same width as the apple, for example, it's just going to graze the side of it. It's not going to actually like grasp it. And when we're picking up like something like a water bottle, you have to really like deform it to actually get a good grip on it, right? So it's similar with robotics as well. So what helps me really understand this concept is actually do this physically with my hands. So, move your hand above like a cup of water, bring it down, grasp it, pick it up and move it. And that's literally what a robot does. So yeah, just a good way to think about it. And so now placing it is basically the opposite. So first you lift the object above the table, move to the location you want it to, move down to the table, and then you open the gripper and let go. And is basically the opposite thing. So just make sure that you kind of understand this process, and just kind of like know that you have to move to the location, pick up the object, and then move it somewhere else, and kind of think about the steps in between those things as well. So also just to this is the kind of end of the presentation in terms of the lectures. So we wanted to talk about other things robots can do. So there's not only robot arms out there. I'm sure some of y'all have seen Roombas and Boston Dynamics robots, and there's also robotic surgeons now. So there's just this whole big world of robots that you can get into and learn. And this workshop is kind of just your entry point. It's kind of a way to just kind of get introduced to it, but there's just a lot of really cool things you can do and a lot of great resources out there. So if you're interested in any specific aspect of robotics or just want to learn more about like what's out there, feel free to reach out to one of us instructors or the TAs and we can guide you along. But yeah. So Alex, are you gonna take this slide or is me?
So yeah, explain the activity first and then I'll finish.
Okay,
That's
cool.
okay
So
with you.
yeah, so this is the last part of the lab. So first you have the option between two things. This will kind of like be a summary of all the things you've learned today. So one, you can make the robot do a dance move, or two, you can make the robot actually go and pick up a block and move it somewhere. So you can get to choose either one. A lot of the code is already done already, so it's just going to be kind of plug and play. So you don't really need to have finished too much of the last lab to finish this one. And also at the end, if there's time, we'd love to do a discussion. So I'm just kind of going to explain it a little bit right now. So imagine we have a robot arm like the one you've been working with in the lab, but it's on a wheeled platform that can move around. It's repurposed to pick strawberries on a farm. And suppose we have a way of getting the 3D position of a strawberry. So we'd want you guys to write down or just talk about in your breakout room, what are some steps that you would need to write into the code to tell the robot arm to get to the strawberry and pick it up and remove it from the vine. And also think about and talk about what are the differences between doing this with something soft like a strawberry and something hard like a block. Like what would you need to consider in the code between those two things? So with that, we're gonna put you guys back into breakout rooms and we'll get started on this.
And so for here, because you get to pick your activity, I let people pick their own breakout room. So we have wait, I changed names again. Yeah, there's going to be a room for the dance putting it together activity, one for grasping, and then another for review. So you can pick which one you want to go into. They seem to have gotten renamed, so I'm going to call dance, grasping. This one will be review of just programming. So if you want to just keep working on programming, you can go there. TAs, you can pick which one you want to do. And yeah, all right. And this one will be, yeah, I'll just keep that one big. Oh yeah, so distribute yourselves.
And what time is everyone back by?
Oh, and this will be until the 20. So in Eastern time, that's at 4:20. So you should have about like 10-15 minutes. Also, if you're not sure how to assign yourself to a breakout room, then you can ask us or just put something in chat and then we can put you in there.
I don't know how to assign myself to a breakout room.
Okay, which one do you want to join?
What is grasping?
That's the activity where you like pick stuff up and place it. You'll be sketching out the procedure and then there's like a fill in the blanks thing.
Could I do that one?
Yep. All right. Enter phones. Okay.
Thank
Oh wow,
you.
everyone's in grasping. Okay. All right. No one wants to do the dance. No. Okay. All right, I'm gonna auto assign people to dance so you can go to wherever.
Would you be able to go in the rooms and capture like videos and?
Uh, I don't know how to do that. Um,
Okay.
yeah, we've been talking about doing a cool thing for dance where everyone makes one and then we can put them all together, but
Yeah.
people don't seem to choose that activity when we give them the option.
Okay.
Do you know Ari Anders?
No.
All right, 10 more seconds and then everyone's back here. Oh, can we still do the like write something in the chat that you learned today? That's kind of nice to do. Well, it's up to you if you want to do it. It can also happen during summary. All right. All right, TJ.
All right, I think people are getting back now. Y'all did great. Saw some cool things. People were trying to add on to the activities as well, so that's a good sign. So real quick, I wanted to do this discussion with folks. So I wanted to see if y'all had any thoughts about this. So just a reminder of what it is. We have a robot arm that can move around spatially on wheels, and we have position of a strawberry. So can you kind of talk through either in the chat or unmute yourself? What steps would the arm need to take to get to the strawberry? So how would it grasp the strawberry? How would it get from point A to point B? Give y'all like 30 seconds. Okay, like 10 seconds. Yeah, there we go. Okay, cool. Yeah, so that is definitely a consideration. So basically what we want the robot to do is basically what I explained in the last slide. We want to basically move to right above the various position, close, and like Kaya said, strawberries are smaller than blocks, so you can't squeeze it too hard. So you have to kind of figure out what is the right grip width that you need to make sure you don't destroy your object. So if you're ever designing robot arms, just make sure you know about how squeezable your object is. But yeah, great job, everyone. So now we'll move into the summary and finish this up.
Yep. Yeah, so what we did today was we learned how to change and to write Python code. We commanded a robot to go to joint angles into a 3D location, and did something with a complex robot behavior. Next slide, please. Oh, yeah. in chat, please write one thing that you learned today. It doesn't have to be one of our learning goals. Yeah, something you learned or did today. That's also nice to see. And then lastly, so while people are writing that, let's go to resources, and then I'll hand it off to Professor Wells.
Okay.
So the Save Your Lab notebook, you can keep the code, and that way you can reference it and then use it and build on it. There's some more information about it. You can, I'll leave this for Professor Wells. We have our contact information here. You're welcome to ask us questions about it. Yeah, thank you so much for joining us. All right, it's all yours, Professor Wells.
Thank you. And we want to say thank you for exploring programming in robotics with us today. And we hope you gain valuable insights, into coding. And this is this is what we want you to continue to do. Keep learning, experimenting, and pushing the boundaries of what's possible with robotics. And hey, let's change some lives together. Thank you for attending today's workshop. Have a great Sunday afternoon.
Thank you so much. This was great.
Yes, I learned a lot. Thank you, everyone. And Jasmine, thanks so much for helping me.
Oh, it's my pleasure.
Thank you guys. Thank you for participating.
Thank you.
Yeah, thank you, everyone.
Yeah, thank you, everyone.
Thank you, everyone.